Hello everyone, welcome to Knowledge Hub by Sri Chaitanya, and we are now going to continue this live session series where I am talking about chemistry from class 11th. In the last class we learned about the mole concept, right? In today's class we are going to learn about mass concept. Mass concept. Now, before I move on to mass concept, let me do a quick recap of what we did in the last class. So, in the last class, what we did was we talked about moles, right? Where moles was 6.023 into 10 raised to power 23 atoms. Then I defined moles for you. Then I talked about atomic mass, molar mass, and how moles happens, and different varieties of moles, calculation of moles from mass, important formulae, some numericals, right, from number of particles, some numericals again, calculation from volume of gas at STP, and finally I left all of you at this question, right. All of you I had left at this question. So let us now solve this question, right, because I left it at that point, right. So what we need is, we need to know how many atoms, molecules, electrons are present in 1 cc of N2O, right, at STP. So let me just take another slide here. So you have 1 cc of N2O at STP. Right. Now, before you do these kinds of questions, remember the very first thing that you need to do is to calculate the moles. How you will do that? Simply, I told you that 1 cc is nothing but 1 ml, right? And we know that at STP, right, 1 mole of ideal gas occupies 22.7 or 22.4 liters, right. This is at 1 atm and this is at 1 bar. Okay. Now, in the question you can see that 22.4, 2244, 2244, right. This you can clearly see in the question, right, because in the question it is like this. So, just as a precaution I am going to take this value, right. So, simply I can say that 1 mole of N2O is same as or has a volume of 22.4 liters. Right. Now, 22.4 liters means how many mLs? We just multiply it by 1000, so it becomes 22.400 mLs, right. And that is what we talk about 1 mole. Now, if I need to calculate how many moles 1 ml of N2O will have, well, simply divide both sides by 12440 ml, and what you will get? Two 2400 ml, and here you will get 1 ml. So this is how many moles 1 ml will have, right. So 1 ml will have these many moles, correct. So in total we have calculated the moles in 1 ml. Now, in these kinds of question, it is important to go to the options also and analyze the options, and based on the options you need to calculate your answer. So now let us have again a look at the options. So what are the options? Options are about atoms, molecules and electrons. So let us calculate first the molecules. How many molecules does this 1 ml have? So this 1 mole means 1 mole of N2O, right? And we know that 1 mole of anything contains how many things? 6.023 into 10 raised to power 23, right? Molecules, in this case, molecules, right? So how you will convert this to this? Simply multiply it by this number. So you will get, for number of molecules, will be 1 by 22400 multiplied by 6.023 into 10 raised to power 23. So what answer can we get from this? We will get it around 6.02, right, divided by 224. If I cancel these zeros out with this, what you will get? Into 10 raised to power 21 molecules, right? So let us check whether, let us just check whether we have this number or not. We have 23, okay, this we have around this. So this is, you know, right, this is same as what we have got, 6.023 224 into 10 raised to power 21 molecules, right? So this option is correct. Now let us try and calculate the atoms, right? Now this is how you calculate the molecules. Now let us see how we can calculate atoms. Remember, the very first thing that you have to do is to calculate the moles, and from the moles you can go anywhere. Let me just clear this out. So molecules is correct. So we have calculated the molecules, 6.2 by 22400 into 10 raised to power 23. These many molecules are there. Now to calculate atoms, first you have to understand how many atoms are present in one molecule. So if I talk about one molecule of N2O, how many atoms are there in this? 2 nitrogen atoms and 1 oxygen atom, right? So there are total of 3 atoms, right? If in one molecule there are 3 atoms, and if there are these many molecules, then how many number of atoms you will have? Simply you multiply them. So number of atoms will be 3 multiplied by 6.2, 22400 multiplied by 10 raised to power 23, and this comes out to be 3 atoms, right? These many atoms. So let us now check whether the question contains these many atoms or not. Right. See, it is coming around 1.88, 1.8. Now, the answer that we have got is 1.86, 18.6. Now, this can be clearly and easily written as, so if you cancel these out and substitute for the decimal, 22 atoms, right? 22 atoms, right? So this is the form which is given to you, right? So the miracle in this question is that second option is correct, the first option is also correct. So now we have calculated the atoms, we have calculated the molecules, now let us move on to the electrons. It is given as electrons. Now how you will calculate the electrons? So this is done, so let us move on to calculating the electron. So let us again write down the molecules. How many molecules have we got? Molecules are 6.02 into 22400 into 10 raised to power 23 molecules. Right, that many molecules you have. So now the way we calculated number of atoms, we are now also going to calculate the number of electrons. So the very first thing that you need to do is to calculate the number of electrons in one molecule, right? How many electrons are there in one molecule? So let us see, if I have one molecule of N2O, right? If I want to calculate the number of electrons, remember that the atomic number of nitrogen is 7, right? So atomic number is what, everyone? Atomic number is nothing but number of protons. And because this is electrically neutral, number of protons will be equals to number of electrons, correct? So as many number of protons or atomic number, that many electrons it will have. Now because you have 2 nitrogen atoms here and each nitrogen atom has 7 protons or electrons, you can say that 2 into 7 plus each oxygen atom has 8 protons, that is equal to number of electrons, it will also have 8 electrons. So these many electrons it will have. This value if you calculate, right, you will have 21, right, 21 only, sorry, 22. 22 electrons, right? This is for one molecule of N2. So how many molecules we have? These many. So if one molecule has this much, then two molecules will have, sorry, these many molecules will have how many? Simply number of electrons will be 6.02 22400 into 10 raised to power 23 multiplied by 22. If you find, this answer will come exactly as given as this. It will come around 1.32, approximately it will be around 1.32 224 into 10 raised to power 23, right? So these many electrons is or are present. So we have calculated the number of molecules, the number of atoms and the number of electrons. So this question which I gave is actually a culmination or a combination of 3 questions, right? So all 3 options are correct and the actual correct answer is this 4th, right? All the above are correct and are actually the correct answers. Now this was a question which I gave in homework. Let us move on to today's concept, where we are talking about the mass concept. See, if I talk about atomic mass, right? If I talk about atomic mass, 1 minute. So let us now right. So if I talk about atomic mass. So what is atomic mass? Simply, what is atomic mass? It is mass of an atom, right? If you have a small atom, the mass of that atom. And what does that atom contain? An atom consists of what? It consists of, obviously it consists of protons, neutrons, plus you have electrons. Right, everyone? So if you talk about an atom, and now I'm talking about atomic mass. Or for now I'm talking about mass of an atom. Simply the mass of an atom will be number of protons multiplied by mass of each proton plus number of neutrons multiplied by mass of each neutron plus number of electrons multiplied by mass of each electron. Mass of an electron, right? So this is your mass of an atom. This is your mass of a atom. Now remember that no matter what atom you have, right, whatever atom you have, mass of proton, mass of neutron and mass of electron will be same for all the atoms, correct? The only difference will be this number, right? This number will be different, right? So now, what is the mass of a proton and mass of a neutron? So experimentally it has been found that mass of proton is equals to mass of neutron comes out to be as 1.66 into 10 raised to power minus 24 grams, and mass of electron is 9.1 into 10 raised to power minus 28 grams. So these are the experimental values, correct? Let us write this down. 9.1, right? Now if you take the ratio here, you just take the ratio here. If you take the ratio here, mass of proton divided by mass of electron, you will get a number around 1840. It simply means that mass of proton is 1840 times mass of electron, right? So why did we do this? Well, this thing will become clear to you. Now you can see that mass of a single proton, what is this? If you see, this is mass of one proton, right? This is mass of one proton. This is mass of one neutron, and this is mass of one electron, right? So why I did this? See, you can clearly see that a proton, right, is 1840 times heavier than a electron, right? So I can clearly say that mass of proton, or because neutron is same, or mass of neutron or mass of neutron is very, very, very large than mass of electron. I think the varies have too much. Mass of electron, right? I can say this, correct? So if I can say this, now let us move on to this equation again, right? So I am going to clear this up, right, and leave you with this, right, where it shows that mass of proton is very, very large than mass of electron, right. So what we have understood till now, we have understood that mass of proton is 1840 times mass of electron, right. And I have told you mass of proton or mass of neutron is very, very large than mass of electron. So if I talk about mass of an atom, which is given by number of protons by mass of one proton plus number of neutrons plus mass of one neutron plus number of electrons mass of one electron. Because these two values, which values? These two values are really larger than this value, I can actually ignore this. I can actually ignore this. Right? So this value is ignored, right? So mass of an atom is actually called a term as atomic number, right? It's called an atomic number, right, denoted by the letter Z. Right. So we ignore this and we write the atomic number as number of protons by mass of each protons, number of neutrons by mass of each neutron. Right. To give you a feel of this ignorance, why I am ignoring this. So suppose values of these two terms, right? If I write the value of Z, right? Suppose the value of these two terms is 100 plus suppose 100 and value of this third term is around 0.000001. Right. The concept of ignoring, what I am talking about, ignorance. So here you can clearly see that if I add them up, the value will be 200.12345. Isn't this approximately equal to 200? Right? It is approximately equal to 200. So what we have done in this approximation, we have ignored this. We have ignored this, right? So same way we can ignore it here. That is why atomic number of Z in logically mass of electron should be taken into account, but because the mass of electron is very, very less than mass of neutron and proton, we mathematically ignore it and say that the atomic number, change this up, it is not the atomic number, it is the mass number. Right. And this is the mass. This is the mass. This is just the atomic mass. This is just the atomic mass, right? So mass of an atom we can calculate through this formula. Is everyone clear in this? This is your atomic mass. Now the term mass number. what will be mass number? Simply, another term we define as mass number, or Z, which is number of protons plus number of neutrons. This term is denoted by the letter Z. Is everyone clear about this? Right. So we have defined atomic mass, we ignored electrons mass, and we defined the mass number. Number of protons plus number of neutrons is your mass number. One more thing, what is your atomic number? So we have something called atomic number. What is this atomic number? This is nothing but number of protons. Right. You have learned about the periodic table. It is based on this number of protons. Now these are the basics that you actually need to know and understand in order to move forward in this concept of chemistry. Right. Now let us see what else we have next. Okay, this I have all explained you. So coming to the concept of standards. Now I am going to clear this out. So what do I mean by standards? Now, so let us move on to standard. Now, let me give you an example. Each one of you actually go to the market and buy 1 kg of rice, right? You will buy 1 kilogram of rice. So, how do you know how much is this 1 kilogram? What is this kilogram? Suppose you buy 4 kilogram of rice. So, the first person who actually got this idea of kilogram, what is this kilogram? If I tell you to go to the market and buy 4 rice, does this 4 rice have any meaning? What? 4 grains of rice? 4 packets of rice? Then each packet how many? No, it doesn't have any meaning. What gives meaning to this number? This kg. Kg is what? Kg is our unit. Right. Now, how do we get to know about this unit? See, every standard or every unit has been defined by IUPAC, right? International Union of Pure and Applied Chemistry. What they do is, for making a standard, we will take, suppose, one cylinder, metal cylinder, suppose this is a metal cylinder, right? And arbitrarily, out of our own whims and fancies, we will say, let us assume this cylinder is 1 kg. Right? And this 1 kg cylinder of a particular metal has been kept in a place, right? So now suppose I have this much amount of rice, right? This is a bag of rice. This is a bag of rice. It's a bag of rice, right? And I want to know how many kgs is this bag of rice. So what I will do is, just be with me on this one. What I will do is, I will take a weighing balance, right? On one side of this weighing balance, I will keep this rice bag, and on the other side, I'll keep this cylinder. Okay, right. So I will keep on adding cylinder. Now suppose initially what was the case? Initially this part where the rice bag is there, this was downsided, right? This was tilted down. Now I keep on adding these cylinders here, right? Like 1 cylinder, 2 cylinder, 3 cylinders until both of them come to the same level, right? Until both of them come to the same level. When they come to the same level, I will count the number of cylinders here. Like suppose here I kept 3 cylinders, and then I can say that this bag of rice is 3 kgs, right? That is the actual weight. So this kg is actually a unit of mass, right? This is a unit of mass, right? That is the concept of units. Similarly, there are many units of mass. Kg, if you know that, it is the SI unit of mass. Normally, you will use this in physics in kgs, but in chemistry, because we have small atoms, small things we are dealing with, kg will not be used much. Mostly, you will use grams, okay, as the unit of mass, right? Now let us move on to the unit of mass that we use in measuring the weight of atoms and molecules. Right? So let me clear this up. Which is called atomic mass unit, or I can say AMU, right? AMU. So what is the standard here? It is 1/12 the mass of one carbon 12 atom. Simply meaning that if I calculate the 1/12 the mass of carbon 12, whatever value I will get, that will be equals to 1 AMU. That will be equals to 1 AMU. Right. And if I want to say that mass of one O atom, how you will write this? You will write it as 16, right, into, see, whenever I was writing suppose 16 kg, you can understand that this unit is multiplied by a number, right? Correct? Unit will always be multiplied by a number to give you a particular value. So this is the unit now. So the number which has to be multiplied by is 16, and unit will be 1/12 mass of carbon 12, right? Or I can write this as, because this is equals to 1 AMU, I can write it as 16 AMU. So this is the mass of one O atom. Similarly, if I want to write mass of suppose one N atom, what it will be? 7 multiplied by 1/12 into mass of 1 carbon 12 or 7 AMU. Right? This is how we follow and work about in calculating masses. Remember, whenever you have an AMU, it means that mass of one thing. This is mass of one oxygen atom, mass of one nitrogen atom, right? Now let us move forward, and this is called, this part is called, I told you, AMU. Right. Now let us move forward to the next concept, and let us now calculate the value of this 1 AMU in grams. So now tell me, how can we calculate the value of this AMU? See, this AMU I am saying, but nobody of us till now know what is this AMU and how can we relate it to the value in grams, right? So let us now relate this value to the value in grams. I am going to clear the screen up. So next I am going to calculate value of AMU in grams. How will you go about it? Simply, I told you that 1 AMU is 1/12 the mass of 1 carbon 12. Right. The mass of 1 carbon 12 is around 1.99 10 raised to power minus 23 grams, right? It is around this much. So if you divide this by 12, you will get a value around 1.66 into 10 raised to power minus 24 grams as 1 AMU. Now think about it, in the same lecture today, I have given this value somewhere else also, right? What is this value actually equal to? I told you mass of a proton, or it is equals to mass of a neutron, right? So there you have it, the fundamental unit of mass. This is the fundamental unit of atomic mass. Fundamental unit of atomic mass. Fundamental unit of atomic mass, which is atomic mass units. So one atomic mass unit is equals to 1.66 into 10 raised to power minus 24 grams. So this much is what it weighs. So if I talk about, if I ask you the mass of one O atom, and this time I am asking you the mass of one O atom in grams, how you will do that? We know that the mass of one O atom is 16 AMU. So simply we know that 1 AMU is this. So multiply this by 16, 1.66 into 10 raised to power minus 24. So these many gram is the mass of 1 O atom. Just calculate this value. There is nothing big in this. Just calculate this value, and these many grams will be the mass of 1 O atom. So are you getting a feel of this atomic mass and this AMU concept? Everyone? Right? So that is what I mean by AMU, the unit of atomic mass. So now let us talk about another thing, the concept of relative mass. Right. Right. So let us talk about the concept of relative mass. 1 minute. The concept of relative mass. So what do I mean by relative mass? Well, understand this, that if I compare my mass with the mass of an ant, how I will talk about it. suppose this is my mass h, mass of human being, and this is the mass of an ant. If I want to ask you, tell me how much heavier I am as compared to the mass of ant, how will you tell me in terms of mathematics, in terms of a value? Well, simply what you have to do is, you have to divide my mass by mass of an ant and you will get some number, suppose 10 raised to power arbitrary 6 kgs, 7 kgs, right? So I am actually 10 raised to power 7 kg times heavier than the mass of an ant. So what you have done this to make me understand, you have actually divided it, correct? So what is this number, right? This is not in kgs actually. Why it is not in kg? Can anyone think about it? Because it is a ratio. Here also you have this mass in kg. Here also you have this mass in kg, right? So this kg and kg will get cancelled out, right? This gets cancelled out and this relative number will be unitless. It will not have any unit, right? So this is my relative. So if I have to put it in words, what this will be? This will be my 1 minute. Yeah. This will be my relative mass, right, with respect to ant. So this will be my relative mass with respect to ant, relative mass with respect to ant, because here I am comparing this, right? Similarly, if I tell you to tell me the relative mass of an atom with respect to 1/12 the mass of carbon 12, then you will get. So what is the relative mass? See, with respect to I am writing in short WRT, right? With respect to, or you can write as compared to, as compared to 1/12 mass of carbon 12. How do we do that? See, this was mass with respect to ant. So we divided the mass of the ant, right? Now this is the mass as compared to 1/12 of carbon 12. So here also you are going to divide by 1/12 the mass of carbon 12. So suppose let me take the example of oxygen again, right? Oxygen 1 atom mass is 16 AMU, right? And what is 1/12 the mass of carbon 12? Suppose I write here 1/12 the mass of carbon 12. 1/12 the mass of carbon 12 is what? Nothing but AMU, right? So this 16 AMU will get divided by again AMU. This gets cancelled out and you get a value of 16, right? So this 16 is your relative mass as compared to carbon 12, right? So now with this complete analysis, if now, see earlier the things were different. So now if I write something here, suppose so if I write here oxygen, I write here 16 and write here 16 AMU. This 16 value is what? What is this 16 value? Everyone, the 16 value is relative atomic mass of O atom, right? And what is this 16 AMU? Nothing but mass of 1 O atom, right? So this number which is written in front of this mass, this is your relative atomic mass, right? This number. And this number is again unitless. So there you have it, the concept of relative atomic mass, right? So we have dealt with the concept of relative atomic mass. Now what else can we talk about here? So let me just go to the slide which talks about this. So this is the same, relative molar mass instead of atomic mass. Now you have relative molar mass. So relative molar mass will be similarly mass of one molecule, if this is not visible, divided by 1/12 mass of carbon 12 atom, right? The relative mass will be the number of times a molecule or an atom is heavier than 1/12 the mass of one carbon 12 isotope, right? That is what relative mass should be. I have already discussed this, right? Now as we are talking about masses, right, this is a list of masses, this is a list, right, of atomic masses that you need to memorize, right? Like hydrogen has 1 AMU, of course, helium has 4 AMU, lithium has 7, right? Nitrogen has 9, beryllium has 9, carbon has 12, right? Nitrogen has 14, oxygen has 16. Then you have fluorine which has 19, neon 20, sodium 23, magnesium 24, aluminum 27, silicon 28, phosphorus 31, sulfur around 32, chlorine around 35.5. Why this 35.5? We'll see to that in a bit. Argon 39.9, potassium 39.1, calcium 40C, only little bit difference is there. Chromium 52, manganese 55, copper 63.5, zinc 65, bromine 80, silver 108, iodine 127, and you have your mercury and lead as well here. So these are the few atomic masses that you need to memorize. Apart from this, rest of the atomic masses will be given. A fact of matter is, after this, see the chromium, manganese, silver, iodine, mercury and lead, these masses will be given to you in most cases, right? So as an exercise, let us try and calculate the molecular masses of these compounds, right? So you have calcium. So first you have to write down the mass of calcium. So if you see the table behind it, what is the mass of calcium? Where can you see calcium? Calcium is here, it is 40, right? So 40, mass of carbon. See, I am just telling you how this table will be useful. Mass of carbon is around 12. So put 12 here. Mass of oxygen 16. There are 3 oxygens. So 3 into 16. How much will it be? Just try and calculate. You have 40 plus 12 plus 48. Right? How much it will be? I think it will be approximately around 100. Right? Now what 100? 100 AMU. For now, talking about AMU. Now hydrogen's mass is 1, right? If you see 1, then you have sulfur will be 32, then you have oxygen which will be again 16, This comes out to be around 98 AMU. This last one, you do it as homework. I'm not going to solve that for you, right? So let us move on to the next concept. That is the concept of molar mass. So, if I talk about the concept of molar mass, for this you have to remember what is 1 mole. 1 mole is what? 6.023 into 10 raised to power 23 atoms, ions, right? Molecules or entities. So what will be molar mass then? Think about it. Mass of these many particles, right? That will be nothing but molar mass. Simply, molar mass is mass of 1 mole of particles in grams, right? Mass of 1 mole of particle in grams. Now this mass has to be calculated in grams. Now how can we calculate the molar mass? Think about it a little bit. Now I am going to clear this out and tell you how do we do that. Now we know, suppose let me take the example of oxygen again, right? So we know that mass of 1 O atom is 16 AMU. See, molar mass is mass of 1 mole, right? This is 1 atom. So 1 mole, for 1 mole you have to multiply this with what? Mass of 1 mole O atoms will be obviously 16 AMU multiplied by Na, which is Avogadro's number. I have already told you that 6.023 10 raised to power 23 is Avogadro's number. Now, see, if you see the definition of molar mass, if you move backwards, you will see that according to definition, it is the mass of 1 mole in grams. So I basically have to convert this complete thing into grams. So how do I do that? Simply, you need to remember what is 1 AMU. What is 1 AMU? 1.66 into 10 raised to power minus 24 grams. So I'll put the value of 1 AMU here. What is the value of Na? 6.023 into 10 raised to power 23. Correct, everyone? Now, if you multiply this value, right, see, this complete is what? This value will come out to be in grams, right? That all of us know. This is a number which has no units. This is a number which has no units. Only unit is this gram. So this gram will come out. So that this complete answer will be in grams, correct? Now, if you multiply this, suppose if you take it as around 1.7, approximately 1.7, and this you take it around as 6.02, and you multiply everything, cancelling out the units, this value will approximately be equal to 1.02, which we can take approximately as 1. Right? We can take this as 1. So this will be equals to 16 into 1 grams. Now this is a very revolutionary concept which we have understood now. Now this is what? This is your mass of 1 mole of O atoms, or I can say it is the molar mass of O. So this is the molar mass of O. So can you just tell, this is the atomic mass. This was what? This was atomic mass. Atom mass. See, this is 16 grams and this is 16 AMU. So what is the difference here? I've just replaced AMU by grams. Yes, you can get the molar mass in grams by just replacing this AMU by grams, and then you will get your molar mass in grams. Let us take one more example. Suppose you have helium. Suppose you have helium. Helium atom, if I talk about, it will be 4 AMU. Right. But if I talk about molar mass of helium, that will be around what? 4, just replaced by this gram. Right. And because this is for 1 mole, the unit is gram per mole. So unit of molar mass is gram per mole. Right. One more thing, nowadays this AMU can also be written as same as 4U. This is unified atomic mass. Unified atomic mass. Right? Unified atomic mass unit. So this was all about molar mass. Now from the previous slide, I already told you that 1.66 into 10 raised to power minus 24 into 6.023 into 10 raised to power 23. This is Na. This is 1 AMU, and multiplying them you will get a value of 1. Right? So I can say that 1 AMU is reciprocal of Na. This is also one of the relations which are asked normally, right? This is the relation, I have written it here also, and you have the unit of molar mass. Right. So that is all about molar mass in this class. Next, we will look at something different. What? You remember the molar mass of chlorine was 35.5 grams per mole. How this 0.5 came? I told you mass was number of protons multiplied by mass of proton plus number of neutrons multiplied by mass of neutron. Right? How this 0.5 came? The complete story to how this 0.5 came and more in the next session. So bye for now, and I want all of you to stay tuned with Knowledge Hub to learn more interesting concepts and to join us in Knowledge Hub family. And to register yourself, kindly scan this QR code and know more about our courses. Thank you. ठीक है.